Let's solve a pulley problem with tension and acceleration, so you can handle any tricky physics question with 100% confidence. In this problem, we have two blocks, a hanging block of mass, small m, and a block of mass, big M, resting on a horizontal surface. The coefficient of static friction between the block and the surface is mu. They are connected by an ideal rope passing over a frictionless pulley. Our goal is to find the exact condition under which the blocks just begin to move. Let's break this down step by step. To analyze the forces, we first draw the free body diagram for each block separately. First, let's look at the hanging block, small m. It has a downward force from its weight, which is small m times g. It also has an upward force from the tension, T, in the rope. Next, the block on the surface, big M. In the vertical direction, the downward weight, which is big M times g, is perfectly balanced by the upward normal force, N. So N equals big M times g. In the horizontal direction, the tension T pulls the block to the right. This is resisted by the maximum static friction force pulling to the left. This friction force equals mu times the normal force, or mu times big M times g. Now, assuming both blocks accelerate together at a rate of a, we can write our equations of motion. For the downward moving hanging block, we have small m times g minus t equals small m times a. For the surface block moving to the right, we have t minus mu times m times g equals big M times a. Here's the trick. If we add these two equations together, the tension T cancels out completely. This leaves us with small m times g minus mu times big M times g equals the total mass, small m plus big M, times a. If we solve for the acceleration a, we find that it equals g times the quantity of small m minus mu times big M, all divided by the total mass. For the system to just begin moving, the driving force must overcome the static friction. This means the acceleration must be greater than 0. Because the denominator of our equation is positive, we just need the top part to be greater than 0. This gives us our final condition. The blocks will move if small m is greater than mu times big M. And that's it.